So, we're talking common denominators today. Common denominators are what math with fractions are all about after 4th grade. It's like the only thing we do with fractions. We need common denominators. Because have you ever heard the idiom apples and oranges?
Yes.
What does it mean? Person really close to the microphone, what does it mean? If you're comparing apples and oranges.
Oh, it's if you're comparing apples and oranges, it means you're comparing them by their features.
What do their features have in common?
The fact that they're both a fruit.
That's about it. So when we are finding a common denominator, really the only thing we have in common are they're both fractions. Can you just smack two fractions together and hope that they join? No, that's not adding. Just like you can't really compare apples and oranges because they're like not the same thing at all. What we need is to make fruit punch. That's from Miss Grace, by the way. I totally stole that. We need to mush them up into a way that they actually get along. Because if you put an apple and an orange next to each other, you go, cool, it's a bowl of fruit. They have nothing in common. If you put 3/4 and 1/3 next to each other, it's the same thing. You go, cool, I can't really do anything with that, but they look real pretty. Smooth, yeah, fancy, equal sign and everything. They can't really do anything with them because they're not cut into the same number of pieces. They don't compare. We need to make a list of multiples, not factors. Not factors. Really not factors. Seriously, not factors. Still not factors. So here's the thing. When we reduce a fraction, we find greatest common factor so that we only have to divide one time. These two numbers are factors. They multiply together to make a multiple. 12 is a multiple of 3 because you can put multiple 3's together and create a 12. You can put multiple 4's together and create a 12. We use factors when we simplify because we're doing division backwards. So what do we need to find? Well, we need to find the pieces. Here we already have the pieces. We need to know how to group them all together. Multiples are flashback to 1st grade. It's your count by lists. It's what you did in 3rd and 4th grade when you were struggling with division. You just counted by. Multiples of 4, 4, 8. Count with me like it's 2nd grade. 12,
16, 20.
I'm going to stop at 5. Why?
Because
I don't feel like doing anything more than that, because I honestly figured, I look right here, this screams out divisible by 3 to me, doesn't it? Also, these are really small numbers. Do I have to stop at 5? No, I don't want to do too much. This is already like a 12-step problem, right? None of the steps are hard, but there's a lot of steps to it. So I don't want to overdo it. I'm going to stop at 5 and see if it works. If it doesn't work, can I add more? Sure. But we already know it's going to. Because we get that feeling, right? You know your multiplication and division facts already. None of the multiplication and division facts you guys are going to do this week are above 3rd grade level. Because we're not practicing multiplication and division facts. You know that. We're practicing making fruit punch with common denominators, which is a big process. So they're giving you easy numbers to do something difficult with so that later on we can do more difficult common denominators because you've kind of got, it's basically training wheels day, right? Count by 3's, right? 3,
6, 9.
That sounds so excited. 9. Class of the Living Dead. Pretend you're happy when you say 12.
12.
Fantastic! Because 12, you pretend that you're happy because obviously 12 is going to be our common denominator. You can divide 12 by 4. You can divide 12 by 3. If you can multiply to build up to it, you can divide by it, right? That's the first step. That's all. We found our common denominator. This is the number at which we make fruit punch. Now we need to take these two fractions, multiply them times something, and get a denominator of 12. By the way, notice we're using that dot for multiplication. In 6th grade, they use a lot of missing numbers, and to represent those missing numbers, they use an X. That's why we stop using an X for multiplication and start using the dot. So really, the question is this. I need 4, I need to multiply it times something, and it needs to equal 12. Sir?
3.
Obviously. Right? If I take this number times 3, I need to change my numerator and denominator in the exact same way, right? So I need to multiply this by 3. Now, I don't know why this works, but this always works. I have 4 in my denominator. I need to change each of these 4 by cutting each of these 4 into 3 pieces. 1 into 3 pieces, 2 into 3 pieces, 3 into 3 pieces, 4 into 3 pieces. What number do I get when I multiply? Remember, multiple groups. 4 by 3. I get 12. What number do I get when I multiply 3 by 3?
9.
9.
I took each of my 3 groups and I cut each of those 3 into 3 more pieces. 3 pieces, 6 pieces, 9 pieces. 4 groups, 4, 8, 4 groups by 3. 3, 6, 9, 12. See, I told you I didn't mind looking stupid on YouTube. Hashtag the math teacher who can't count by. Why does this work? Do you remember the identity property of multiplication? Anything times 1 equals itself? One group of stuff is just one group of stuff?
Yeah.
What's this fraction equal to?
Udo.
1. Yeah. I have 1 pizza, I cut it into 3 pieces, and I kept them all. Pizza. Still just 1 pizza, right?
Yeah.
Mm-hmm.
The word manipulate. If a person is manipulative, they play games, right? They mess with people. We're manipulating the pieces. We're messing with the pieces. We're using number tricks. This is just some weird, tricky way to look at this number as something different than 1. Is this equal to 3/4? No, it's equivalent to 3/4. It's basically the same thing, it just looks a little different. Right? 3 times something equals 12. Yes, ma'am.
4.
Yeah. 3 times 4 equals 12. Same thing top and bottom, so this is a fraction equal to 1, so our identity property of multiplication stays true. This multiplication, I really hope somebody is about to raise their hand and answer. Yes, sir.
4.
Yes, sir. Another, it's identity property of multiplication. One group of a thing is one group of a thing. Is this fraction equal to this fraction?
Yeah.
No, it's equivalent. It has the same value, even though it's cut into a different number of pieces. Now we've got fruit punch. Our apples and oranges can be added together. 9 apples out of 12, plus 4 oranges out of 12. How many do we end up with? 13 twelfths. But here's the deal of the day. While we are practicing making equivalent fractions, I don't want you to worry about reducing for 2 days, today and tomorrow. I do not want you to worry about reducing. We're going to practice our skills separately. There's no use to learning how to ride a bike and juggle at the same time. They're both hard enough on their own. By the middle of next week, you're going to be riding a bike and juggling while standing on your head. Like it's this stuff, once we get our feet underneath us and we start working with the pieces, is just not really all that bad. But it does take a lot of practice to get good at it.